Hello, we're going to look at transformations. One of the most useful graphs when you first look at transformations is the graph of y equals square root of x. We'll come back to the handy points of 0, 0, 1, 1, and 4, 2. So the old y got calculated and then you subtracted 2. The old y got calculated and then you added 2. So any time that you take any graph, x cubed, square root of x, absolute value, log graphs, any graphs, compare y equals the square root of x to y equals the square root of x plus 2, and y is the square root of x minus 2. You can see that compared to the original graph, when you added 2, it went up, and when you subtracted 2, it went down. And so every coordinate on the original graph, you're going to be adding 2 to the y's. What happens when we change x before the square rooting happened? I've shown you the results of two functions. At the top, you see y equals the square root of x minus 3, in which our graph seems to be the same shape and has moved to the left 3. And at the bottom, it is the square root of x plus 3, in which our graph is the same shape, except it has moved to the right 3. Take any function, add a number when it's over, and you're adding that a to y. Whether that a is a positive 2, as in our first transformation, or a negative 2, as in our second transformation. Let's look at this example, y equals square root of 3x. Here the x is being multiplied by 3 before the square root function happens. So let's start with the parent function, y is square root of x. You've got the points 0, 0, 1, 1, 4, 2, as we saw in the beginning, and there's a little graph of the square root of x. My transform function, I'm going to divide the x by 3. So to get my new function, I'll take all the old points and divide the x's by 3. 0 divided by 3 is still 0. 1 divided by 3 is 1/3. 4 divided by 3 is 4/3. Don't change the y's. I draw the new graph. Compared to the old graph, all the x's are 1/3 the distance they used to be from the y-axis. You could do this entirely visually by just taking the points on the original graph and making them 3 times closer and getting the new graph. If the change happens after the function process, make that change to y. If we have y equals 5 square root of x, we're going to multiply y by 5 because square root of x is the old y. We just changed the old y by multiplying by 5. If we have y equals negative 1/2 e to the x, e to the x would have been the old y, and we just multiply the old y by negative 1/2. You don't need separate rules for negative multipliers. Y equals negative 1/2 x squared. So my parent function is going to be y equals x squared. Some handy points on that are negative 1, 1, 0, 0, 1, 1, 2, 4. Now to do my transform function, here's my old y, x squared. I'm going to multiply my old y by negative 1/2. 1 times negative 1/2 gives me negative 1/2. 0 times negative 1/2 gives me 0. 1 times negative 1/2 gives me negative 1/2. And 4 times negative 1/2 gives me negative 2. So these are the points on my new transformed function. In summary, if you add an a to your x before the function happens, you're going to be subtracting the a. If you do your adding a after the function happens, outside the parentheses, outside the radical, you're going to be adding a to the y. If you multiply your x by a inside the parentheses, inside the radical before the function happens, you're going to be doing the opposite, dividing your x by a. Where if you multiply by a after the function happens, you're going to be multiplying by a. In essence, if it's happening inside the function, inside the parentheses, inside the radical, it works the opposite to the way it looks. But if it's outside the function process, outside the parentheses, outside the radical, it happens the way it does look. What if multiple changes occur? Follow the order of operations. Look at this function, y equals 2 square root of x minus 3 plus 1. The 2 is going to be changing the old y. You're going to multiply your y by 2 because it's outside the function. 3 is going to be changing the x by adding 3 to the x. The 1 is going to be the old function over here is done, and you're going to be adding 1 to the old y. You have multiplying and adding going on, so we're going to do the multiplying, higher order of operation first. Since the other two affect different values, one's x, one's y, any order is fine. So my parent function is y equals the square root of x. I'm going to do that first. And whatever your parent function is, get some really useful points for it. 0, 0 is always handy for this guy because it's where it starts. 1, 1, and 4, 2 are nice points because they are integers. Then I'm going to do my multiplying first. I'm going to take my old y, multiply by 2. 0 times 2, 1 times 2, 2 times 2. Okay, we need to finish it off. We've already done the multiply y times 2. So let's add 3 to x and add 1 to y. It doesn't matter which order you do those in because they're affecting different values. So here I added 3 to each of my x's, added 1 to each of my y's. Could have even done those at the same step. And here's my final graph. What if our function is y equals 3 square root of 3x minus 6? The 6 is not changing x, it's changing 3x. So when you rewrite it, the 3 is dividing the x by 3, and the 2 is adding 2 to the x. By order of operations, we do the dividing 3 first. So we start with our friend y equals the square root of x, our handy 0, 0, 1 more 1, and 4, 2. We divide x by 3 first, so we go through all of our points and divide x by 3. And then we take all our points and add 2 to x, and we're ready to graph.
This technique works with any kind of function. Here it's working with a cube root function. We can't assume that we're subtracting 3 from x because this is 1/2 x plus 3, not x plus 3. So in this situation, because there's multiple things happening to the x, we need a rewrite. So we factor out the 1/2 and write the radicand as 1/2 times the quantity x plus 6.
Now that we have our rewrite, the negative says we're going to multiply y by -1. The 1/2 says we're going to divide x by 1/2, happening inside the radical. The plus 6 to x says we're going to subtract 6 from x. And the subtract 4 at the end is out of the function process, so we're going to subtract 4 from y. We're going to start with our friend y equals cube root of x. -1, -1, 0, 0, 1, 1, 8, 2 are all handy points. Do the multiplying and dividing first. I'll handle the x operations first, so I'll divide x by 1/2. And then subtract 6 from x. My y operations are multiplying and subtracting, so multiplying happens first by order of operations, so I'm going to multiply all my y's by -1, and then I'll subtract 4 from all my y's, and give me points on the final graph. And here's my final graph.